All right, we are back, and that was Rush's Tom Sawyer to bring us into number 2. This was number 1, Taylor Maclaurin series practice examples number 1, but now we're going to do number 2. Discuss the creative ways to, and then write the first 5 non-zero terms of the Maclaurin series for each of the following functions. You're like, what? There is no one way to do these. Pick the way that makes the most sense to you. We're going to do problem 2 on Taylor Maclaurin practice examples. Okay. E to the 3x. Now, of course, we could always use this good old formula, f of 0 plus f prime of 0x plus f double prime of 0, x squared over 2 bang plus f triple prime of 0x cubed over 3 bang plus the nth derivative at 0x to the nth over n bang, but this takes forever sometimes. Besides, if we know the series for E, which we do, if we know the series for ln, which we do, if we know the series for cosine, which we do, you're like, what about that x? We'll talk about that in a second. If you know the series for sine, what the heck is going on with? Don't worry, relax. If this is a question they ask you, you can very easily modify it. Okay, so first, you know that the e to the x series, goes e to the x equals 1 plus x squared over 2 bang plus x cubed over 3 bang plus, and so on and so on. So there's our first 5 non-zero terms. There's our nth term, x to the nth over n bang, and the interval of convergence is, of course, all reals. What? Okay, now we're just going to modify this. So we're just going to go 1 plus 3x plus 3x squared over 2 bang plus 3x cubed over 3 bang plus, can you see that okay with my hand? I hope so. Plus 3x to the 4th over 4 bang, 3x quantity to the nth over n bang. Similar, not similar, same interval of convergence, but if we want to clean this up a little bit and make it look a little bit more like a series with actual integer coefficients or rational number coefficients, we're going to go 1 plus 3x plus 9x squared over 2 bang plus, and just like the last one, if you want to call it 3 cubed x cubed over 3 bang, or 3 to the 4th x to the 4th over 4 bang, that's fine. There's my first 5 non-zero terms. 3 to the nth x to the nth over n factorial also, and there is our answer for the first one. Now the second one, now we got to think about this one for a minute. Now this guy, we know that the series for ln of 1 plus x, you're like, I don't remember that. Okay, if you don't remember the series for ln of 1 plus x, you might remember the series for 1 over 1 plus x because it's a infinite geometric series sum form. First over 1 minus r, 1 minus negative x. Looks like I'm multiplying by negative x every time. Let's multiply by negative x every time. Oops, almost messed up. Let's multiply by negative x every time, blah, blah, blah. So this guy is going to be term by term integration. And I'm going to go, I'm going to go x minus x squared over 2 plus x cubed over 3 plus x to the 4th over 4, etc., etc. Ooh, I did it again. Oops, I did it again. Okay, so now what I'm going to do is instead of it being ln of 1 plus x, it'll be ln of 1 plus something different, and that's something different being 9x. Here we go. 1, oops, just kidding, x, which is now 9x, 9x minus 9x squared over 2 plus 9x cubed over 3 minus 9x to the 4th over 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, oops, we need one more, plus 9x to the 5th over 5, I guess this would be 9x to the nth over nth, but wait, Mr. Mac, don't forget about the sign flipper. So if you put in negative 1, I'm going to put in a 2, oh, it's going to be negative, I'll go n plus 1. Now, think. This is not great. So I'm going to call this 9x minus 9 squared x squared over 2 plus 9 cubed x cubed over 3. Please don't simplify these. Just leave it. Just leave it. Leave it. My goodness. Plus 9 to the 5th, x to the 5th. Please send your mistake comments or what do we call it? Complaints to the Office of Complaints located at 821 South Sullivan Road, Spokane Valley, Wa. 90, shoot, I don't remember our zip code. 99037. But don't. You can if you want. The interval of convergence, but you must fill it out in triplicate. Interval of convergence usually is, for this guy, would be -1 to 1, which means this one would be -1 to 1, including, I got to think about this for a minute. It's going to include the 1, because the 1 will be a sign flipping harmonic. The -1 will be -1, -1. I'm thinking that's a diverger. That's a negative harmonic. Okay, so we're just going to trust that. And we're going to go, if I put in a 1/9, it would produce the same one as this guy did with the 1. If we put in a -1/9, it would also produce the negative harmonic. So there's our interval of convergence. Okay, so we're going to go with this. Okay, now, number 3. Now, this one is the nicest of all, because this guy, all we got to do is remember the cosine series. So this is going to be x times the cosine series, which is 1 minus x squared over 2 bang plus, everybody now, x to the 4th. Yeah, minus class cadence. Yep, plus, oops, x to the 8th over 8 bang. Minus 1, 2, 3, 4, 5. 5 non-zero terms. So we're going to stop it there for a second. So we're going to go distribute this into all of these bad boys and go x minus x cubed over 2 bang plus x to the 5th over 4 bang minus x to the 7th over 6 bang plus x to the 9th over 8 bang. 1, 2, 3, 4, 5. Good. Now, I'm instead of modifying the nth term that I know for cosine, I'm just going to build it from here. I notice how I always have a 2n bang on the bottom. Looks like we have 2n plus 1 as the power on the x. But if I put in a 2, that gives me a 5, which is this guy. So I'm going to go -1 to the nth. I think this is good. I think this is good. I think this is good. It's good. And because it's a modification of a cosine series whose interval of convergence is all real numbers. There we go. Last but not least, this bad boy. Now, this is so confusing. You're like, what the heck am I supposed to do with this? Look at this thing. There's all this stuff. But don't forget, you're just supposed to put the whole entire sine series right there, the infinite sine series right there, getting rid of the first 2 terms. But remember, this is a nice hint that tells you that these are the first 2 terms, the opposite of the first 2 terms of the sine series. So we're just going to go ahead and put the entire sine series, everybody now, x minus x cubed over 3 bang plus x to the 5th over 5 bang minus x to the minus the x plus the x cubed over 3 bang all over x to the 4th, which is kind of strange, but this guy, get your mad slashing hands out, and it looks like every single one left has at least a power of 4. 5, 7, 9, but I need 5 non-zero terms, and I've only got 2 left. No worries, you'll see the pattern. So x to the 5th over x to the 4th is x over 5 bang. You can see that down there, yes. Minus 7 over 4 is 3 over, I need to keep track of these, 7 bang, plus x to the, okay, hold on. So that would be an 8, set a 9. A 9 over 4 is 5. I'm going to do the powers really quick. 1, 2, 3, 1, 2, 3, 4, 5. 1, 3, 5, 7, 9. 5, 7, 9, 11, 13. Ooh, that was kind of cute. Bang, 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 bang. Minus, plus. Okay, I think we're okay. So now, I think the bottom, we're just going to call the bottom 2n plus 1, because that's like a nice, yeah. Okay, this is going to take a little bit of work. If we call this 2n plus 3, we can start with we can start with a 1. Am I right? If we call this 2n plus 3 and stick in a 1, we can get the 5. So let's try that. 2n plus 3, bang, on the bottom. Now if I stick in a 2, I'll get 4 plus 3, 7. Good. But if I stick a 2 into here, I'll get the 3 as the power. So this needs to be, okay, hold on, I go back to here. 2, 4 minus 1, maybe 2n minus 1? Let's try that. Stick in a 3, 6 minus 1, stick in a 4, 8 minus 1. Now this can vary, of course, as long as these powers are, I gotta say this carefully, 4 apart? 5, 9, 7, 11, 9, 13. We need the good old sign flipper. And we need to stick in a 2, which gives me a 3, which gives me this, and it's going to be an n plus 1. Did I do that right? Did I do that right? Stick in a 2, stick in a 3, it gives me the 5, which gives a positive. Hey! And then my interval of convergence is the same as the original sine series, because that's what it was built off of. And there, voila, with my 1, 2, 3, 4, 5, we have 5 non-zero terms. And there, my friends, is how to create Maclaurin series based off of known series, not needing to use the old formula. Thank you very much. On to number 3.